Welcome back, pre-calculus students. Today we're going to talk about finding the area of a segment in the circle. And if you're using the 2019-2020 book, we're going to start on page 70. So let me just insert. So let's say I have a circle and I'm trying to find the area of this shaded piece right here. We don't really have any formulas to find the area of that shaded piece. We do know how to find the area of maybe the whole piece, which we would call the blue piece. We used to call a sector in geometry. We don't want the area of the sector. We want the segment, the red piece. So how we're going to do this is the following. We're going to find the area of the whole sector. Let me insert a new picture really quick. So we're going to find the area of the whole sector, this whole blue piece. Because this blue piece is the part or a piece of the pie. And if we can find the area of the whole circle, then we can find the area of a piece or a part of the pie. And then we're going to subtract away this red triangle that I'm drawing, which will leave us with our answer, the green segment that we're looking for. So let's flip to page 71 and talk about how we're going to do this. So on the top of page 71 is kind of the outlined formula. We're going to find the area of the segment. The segment again is this little piece right here. That area of the segment is going to equal the area of the sector, the whole piece of the pie, minus the area, minus the area of the triangle, which is this piece right here. And then this piece I'm circling in blue will be the piece that's left over right there. So let's talk about formulas. The area of a sector, a part of a circle, the area of a circle is pi r squared. This piece is area of, it's the area of a circle, but I don't want the whole circle, I want a part of the circle. So we're going to do theta over 360 degrees, where theta is my central angle. So for example, if this central angle, this theta in here was 60 degrees, then I'd have 60 over 360. And then the area of the triangle, well, on this triangle I have a radius and a central angle. So this looks like that formula we learned at the beginning of the law of sines, where we did the area equals, so we're going to do this piece right here, minus that 1/2. It was side, sine the angle. So in our case, it'd be r times sine of theta, because here are my two r's, and then my included angle in here is my theta. So this is the formula we're going to use. So let's do some practice. Let's do where it says let's practice on page 71. Okay, so it says example 1. Find the area of a segment of a circle with a central degree of 120 degrees. I'm going to go ahead in here and add a little degree symbol to help us remember, and a radius of 8. So let's see. If I want to do the area of the circle, which is, I'm going to do the sector piece first. I'm going to do the pi r squared, but in my case it's going to be pi times, my radius is 8 squared. And then don't forget, in the front here, we don't have a whole circle. Pi r squared is a whole circle. I want just part of the circle, that theta over 360. So my central angle is 120 over 360 degrees. And I'm going to simplify this one time, because 120 over 360, that's a third. And then pi times, we know that 8 squared is 64. So this is the first piece. And then I'm gonna minus away the area of the triangle. That area of the triangle, I know this side over here is also an 8, so I'm gonna use that 1/2 A times B times sine of C formula. This is my A, this is my B, and this is my included angle, big C. So this is gonna be, I'm gonna subtract away 1/2. I'm gonna have an 8, an 8, and a sine of 120 degrees. So 8 times 8 is 64, and half is 64, so I'm gonna do the half times the 64. That makes a 32 sine of 120 degrees. And you can literally just type this in the calculator the way that it is. So this area of the segment that we're trying to find equals the 1/3 times pi times 64 minus 32 sine 120 degrees. So let me type this in my calculator real quick. So I've typed this in my calculator. Let me add a picture to help you out really quick. So you can see here on my calculator screen, I have these parentheses. These are very important. Keep my things together. I've inserted time symbols in between. And then I also remembered my degree symbol. Let me erase so you can see it really quick. So I typed it just like that, and then I'm gonna press enter to get my answer. Let me shrink this picture way down. So I'm gonna press enter, and you're gonna get that your answer approximately to 3 decimals. So I'm gonna write it up top so I don't have space at the bottom, but the area should come out to 50.063. And remember, story problems have story answers. It doesn't have a label on the units, so we're just gonna call, or on the radius, so we're gonna call it units squared. So that is your answer for practice number 1. So let's go try practice number 2, or example number 2 on page 71. So example number 2 is just a little bit more difficult, and it's because you don't know the central angle. So go ahead and take a moment and read it. So it says that I have this triangle pretty much that has side lengths of 5, 5, and 7. The radius is 5. I need to know that theta, that central angle, or I can use Heron's formula. The problem is that I need to know that angle really, because I need to do that piece where it says theta over 360 degrees. So instead of using Heron's area formula, which you can absolutely use to find the area of the triangle, I am going to go ahead and find the theta using law of cosines, because I need the theta for another part of the formula anyways. So law of cosines says a squared equals b squared plus c squared minus 2bc cosine A. In our case, I'm going to call this, the 7, I'm going to call little a. So that means this theta that I'm trying to find is A. So over here, I'm going to call that a theta. That's what I'm really trying to find. And then my 5 is a B, and my other 5 can be my C. So in my formula, I'm going to have 7 squared equals 5 squared plus 5 squared minus 2 times 5 times 5 cosine of A. Okay, we got this. So I'm going to have 7 squared is 49 equals, this is a 25 and a 25. 25 plus 25 is 50 minus 25 times 25 times 2 is going to make a minus of 50, but this second 50 is tied to my cosine A. So if I want to solve here, I'm going to minus this 50 over, minus this 50 over. 49 minus 50 is going to make a negative 1 equals negative 50 cosine A, because this negative sign that I have right here in front, I got to keep that negative. And so now I'm going to divide by negative 50, divide by negative 50. So 1 over 50 equals cosine A. I need to get to the A or the theta. So in my calculator, I'm going to type arc cosine of 1 over 50. And as long as my calculator's in degrees, it will spit out my degree answer for me. And if it's not in degrees, you're going to multiply by 180 and divide by pi. So let's type this. Arc cosine of control divide 1 over 50. You should get that the theta is equal to approximately 88.854 degrees. So now let me take all this and, oops, that's not what I wanted to do. It's not letting me make things smaller. There we go. Okay. Let me make that a little bit smaller. So now I'm going to use that central angle. I'm going to use this in my formula. I'm going to do the theta over 360 degrees pi r squared minus that 1/2 AB sine C, which in our case is also a theta. This angle and this angle always end up matching up. So here we go. I'm going to do 0.854, there's a decimal there, over 360 times a pi times my radius is 5 squared. I'm going to do this whole piece minus 1/2 5 times 5 sine of the 88.854 degrees. I'm just going to type this whole thing in my calculator with parentheses and the degree symbols all at once. So again, let me grab a picture of my calculator screen to help you out, just so you can see how I typed it. So here's my calculator screen. I typed it just like I said I was going to. Make note right here, you gotta put a time symbol in between the 5 and the sign, and this little piece right here, this -1 power, should not be there, right here. So that's what your calculator screen should look like. And then you're gonna press enter and you're gonna get your answer. So let me shrink down this calculator screen and put it down here in the corner. And you should get that your area, the area of that segment, is approximately 9.676. The lengths in the problem were inches, so this is inches squared. We're going to skip problem number 3 and we're going to do example number 4. So example number 4, I'm going to draw it this time. So here's my beautiful circle. I know I'm such a great artist. Good thing I can insert some pictures. Example number 4 says that here's a 7 and a 7, and they're telling us the central angle in here is equal to 2 pi over 3. So the reason I want to do this problem is that this time this theta, the central angle's in radians. So instead of doing theta over 360, because that was when I was in degrees, I'm going to do theta over 2 pi, because in radians the whole circle is 2 pi. But everything else is going to stay the same. So I'm going to do the theta over, this time 2 pi, times pi r squared for the circle, minus that 1/2 a times b times sine of c, which is also my theta. So I'm going to have 2 pi over 3 over 2 pi times a pi times 7 squared minus 1/2 times 7 times 7 times sine of 2 pi over 3. This is a radian, guys, a radian. So your calculator needs to go back to radians or you won't get the right answer. I'm going to simplify this fraction right here. This fraction right here, this 2 pi over 3 over 2 pi, this 2 pi on the bottom is like over 1. And then my favorite song is dividing by fractions is easy as pie. Flip the bottom and multiply. So you take the bottom and you flip it over and you multiply like this. The 2 pi's are going to cancel out, so this is equal to 1/3, which makes sense because I drew about 1/3 of the circle. So down here I really have 1/3 times a pi times 7 squared is 49. Minus, right here again, 7 squared is 49. So 1/2 times 49 times, I'm hoping some of you remember that sine of 2 pi over 3 is a root 3 over a 2. But if you don't, it's okay. We can type it in our calculator. But again, your calculator needs to be in radians because this is a radian measure. Otherwise, you won't get the right answer. So I'm going to type the whole thing in my calculator. My calculator is going to be in radians, and I'm going to get an answer. So go ahead and pause the video and grab your calculator and see if you get the same answer as I do. And when you type all this, you should get the area is equal to 30.095. Story problems of story answers. There's not a label on the 7, so we're going to call it units squared. Just want you to flip for a second to page 72. Number 1 we've done, number 2 we've done. Number 3 is not the area of a segment, it's just a triangular lot. Number 4, I want to draw you a picture for really quick, just in case you want to do the practice. Number 4 says that you're going to make a cone, you're going to make a tent from a cone. So on number 4, I have a whole piece or a whole circle and I'm going to make a cone. So what you're going to do is you're going to cut this piece out and then fold the two pieces together. So it makes kind of like a cone, like a teepee. So you're taking out this piece. So that should help you do number 4. So it's number 4 on page 72. And then for number 5, it gives you a hint. It's a right triangle, but I also want to give you one more hint. Instead of doing theta over, let me erase that, that's not what I meant. Instead of doing the theta over 360 pi r squared for the area of a circle, you can do theta over 180 because you only have half a circle, or you can take this whole piece right here and multiply by a half because the piece in number 5 is not a whole circle, it's a half a circle. Hopefully that helps you do some more practice problems. Remember, your teacher has Zoom office hours, and there is stuff linked on Canvas for you to complete in regards to the area of a segment of a circle.